The organic family we will be discussing today is the amine family. An amine is an ammonia molecule in which one or more hydrogen atoms are substituted by alkyl or aromatic groups. The general formula for an amine is: here, R represents a hydrocarbon group that is attached to the molecule. The three R's can be the same or different groups. There are three different types of amines: primary, secondary, and tertiary. A primary amine has one hydrocarbon group attached to the nitrogen atom. A secondary amine has two hydrocarbon groups, and a tertiary amine has three hydrocarbon groups.
To name amines, we follow a specific outline that consists of 3 steps. The first step is that you must locate and name the hydrocarbon chain with the YL ending. Next, you add the word amine to the end after the YL ending. Finally, any alkyl groups that are connected to the nitrogen atom are located with the letter N instead of using the usual number locating system. For example, when given the model, we first name the hydrocarbon chain with the YL ending, which in this case would be ethyl. Then we add the word amine after to make ethylamine. Since there are no hydrocarbons attached to the nitrogen, we do not need to include this step.
Now, when given a model that does have a hydrocarbon chain attached to the nitrogen atom, such as this one, we follow the first 2 steps to name it propylamine. Now, because we have a single carbon chain attached to the nitrogen, we use the normal methyl prefix to describe it, but use the letter N to locate its position on the chain. There are 2 types of polar bonds in amines. One is the polar bond between nitrogen and carbon, and the other is the polar bond between nitrogen and hydrogen. These polar bonds increase the intermolecular forces of attraction in the molecule. There is also hydrogen bonding between nitrogen and hydrogen.
Smaller amines are readily soluble in water because it contains these polar bonds, and polar substances dissolve in other polar substances. Amines also have higher melting and boiling points than hydrocarbons of similar size because of their polar bonds. Amines are prepared by the reaction of ammonia with an alkyl halide. For example, the reaction between ethyl iodide and ammonia to create ethylamine, which is a primary amine.
The primary amine can then react with alkyl halides to form a secondary amine. For example, the reaction between the primary amine, ethylamine, and ethyl iodide to create the secondary amine, diethylamine.
The secondary amine can then react with an alkyl halide such as ethyl iodide to produce a tertiary amine, triethyl.
Amines react with carboxylic acids to produce amides. These reactions are condensation reactions that form water. For example, the reaction between ethanoic acid and ammonia to produce ethanamide and water.
This equation illustrates the reaction of a carboxylic acid and the simple amine ammonia to form water. This concludes our lesson on the organic amine family.